Hello everyone and welcome back to this channel. I just request you to like, share this video with your friends and also to subscribe to my YouTube channel. Like you can already see on our screens today, we are going to be learning the introduction to matrices, which is going to form a series of videos with regards to matrices. That is the operations, things to do with determinants, and also all through to application of matrices in solving simultaneous equations. So generally, when we talk of matrices, we are talking of numbers which have been arranged into rows and columns. These numbers form what we call the elements of a matrix. So that if we have an example of a matrix 2, 4, 6, minus 1, we can already see that this is a matrix that is arranged in rows by what we're calling the columns. And the number of rows here, when we look at it keenly, we can see that we have this 1, 2. So we have 2 rows by 1, 2. This becomes 2 columns. This becomes a 2 by 2 matrix. Now, when we look at another one, an example, we can have 2 minus 1, 0, 4, 3, negative 2. This one, we look at again at it in terms of rows and columns, then we can see we have this row. We have this second row. So we have 2 rows. When we talk of rows by the columns, we have 2 rows by 1, 2, 3. So these are 2 by 3 matrix. And whatever we are seeing inside here as the 2, we have minus 1, we have minus 2, we have 0, we have 3, and we have 4. These ones are what we are calling the elements of the matrix. So like we've seen, we can arrange the elements so that we have them in terms of rows and columns, and that forms what we are calling our matrices. Now another example, let's have another example of maybe a 3 by 3 matrix, so that we have minus 1, 4, 5, 0, 2, negative 3, 8, 7, and 6. Now, when we look at this one becomes a 3 by 3 matrix because it has number 1 row, number 2 row, and number 3 rows, and also number 1 column, number 2 column, and number 3 column. So this one, when we talk of it in terms of row times the columns, it becomes a 3 by 3 matrix. Now, I want us to proceed further and look at the arrangement that we can just a minute. I want to move this one up a little bit. Now, one last thing before we conclude this video. Now, remember we have seen a matrix in terms of rows by the columns. An example of it, we have seen a 2 by 3 matrix. Now, if we look at this example, a 2 by 3 matrix, so that we have 2 minus 1, 4, and maybe 0, 4, and 3. When we look at this matrix, and think of it, of the elements being positions in terms of a coordinate. A coordinate will look like something like this, where we have the y-axis and we have the x-axis. So that if you have a position of something, then normally we say the x by the y to give us the position of that value that we are looking for. So if we look at this matrix, they are also arranged in somehow something that looks like that. But now in ours, we are talking of the rows. Remember, this is the row number 1, this is the row number 2. So we are talking of the rows by the columns. This is the column number 1, column number 2, and column number 3. So that we can actually describe the position of each element in terms of rows by the column. For example, this value 2, we can say it is in row number 1, column number 1. So we can say the element is, if we look at it as, we can say this is A 1 1, because this number is in the row number 1 and the column number 1. The other one, which is -1, we can say it is A 1 2, because it is in the row number 1, column number 2. The other one is in A 1 3, and we can continue with that all through. We can also look at another example now and we can call this a matrix A. Let me just divide this into 2. Let's have a matrix A, which is described by 2 4 3 1 0 4 -1 6 7. This is a 3 by 3 matrix. So for this 3 by 3 matrix, we can describe the position of the elements and say, in terms of this A, we can say we have this 2 is in the position A 1 1. This 4 will be in the position A 1 2. 3 will be in the position A 1 3. We go to this 1 in the second row and first column. This will be A 2 1, because in our second row, column 1, and then 0 will be in A second row, column 2. 4, our 4 here, is going to be A second row, column number 3. Then in the last row, we have -1, which will be A. It is in row number 3, column 1, so 3 1. 6 is going to be A, is in column number row number 3, column number 2, so 3 2. And lastly 7 is going to be A, row number 3, column number 3. So these ones, we can easily describe the position of any element by describing them in terms of the rows and also in terms of the columns. Now, one more last example. Assuming that we have a matrix 2, which is, let's say it is A, which is 2 4 3 1 6 0. We have this matrix. Then you are told to describe the position of element 6, position of element 0, and position of element 2. You can just pause a little bit and ask yourself those positions there. Now you guessed it right. Now for 6, we can see that this is the row number 1, row number 2, row number 3. So it is A 3, and it is also in column number 1. So A31. So that will describe 6. For 0, it is again in row number 3, which is A3, but now this is the second column. So A3 2. And lastly for 2, it is in row number 1, column number 1. So this will simply be A1 1. So up to that point, I hope we've learned a lot on introduction to matrices. In our next lesson, we are going to be looking at operation on matrices, that is addition and subtraction on matrices. Otherwise, thank you very much for going through with me all through to this point. I still request you to subscribe, like this video, and also share it with your friends. Those, bye bye.